Hi, I'm Michael Scott, and my informative speech will be about computers, specifically how your computer will perform its daily functions. To start, let me ask you a question. Did you know you're watching this on a computer? Yes? Well, how about did you know you are a computer watching this on a computer? That's right. According to computerhope.com, a computer is defined as a device that can intake, store, and recall information for later use, thus making all of us computers. In today's day and age, we are near powerless without computers. They are essential for a large majority of daily tasks, such as checking your email. However, a large number of people do not understand how our computer works. The device so integral to our tasks is an enigma to most. So, in this speech, I will inform you all of the complex foundation of computers and the electrical components they are made of, as well as how those components use electricity to send signals and how those currents use logic to become the image on your screen. Finally, I will explain how those tiny wires and other parts are combined to make things such as a motherboard, and CPU. Every device anyone uses today will contain what is called a circuit board, a plate normally made out of fiberglass with conductive paths on them that are normally called channels made from solder. These circuit boards are what any computer part will be made out of. No matter the name for the connection, at the end of the day, it is still a circuit board. On any board, you will find a circuit. This is an unbroken electrical loop of channels. If there is a break in the circuit anywhere, it will cause a short and the circuit will no longer receive power. For a circuit to function, the current entering the circuit must be the same as the current exiting the circuit. This is achieved by the creator of the circuit board adding our first set of devices to the circuit, which simply modifies the current by taking away energy or adding energy in to ensure the circuit remains balanced. Now that we have the physical aspect of circuitry out of the way, we can move on to the electrical aspect. How can a circuit with the purpose of solely carrying electricity let us look at pictures of cats on the internet? Well, we begin by making the board think. Circuits can use a type of circuitry called logic gates. These gates use different combinations of current input to decide when it will allow a current to flow through. For example, a few types of commonly used logic gates would be AND, OR, and NOT gates, which allow us to use something called Boolean logic. Boolean logic, created by George Boole, is a system that translates complicated binary answers into a simpler binary variable used to represent one of those two outcomes. These variables are a 1 or a 0. This value is a bit. The two variables can represent any number of binary outcomes and simplify it as a 1 or 0. Binary allows us to make a language that the computer can understand out of these ones and zeros, being powered or not powered, and layering these binary statements on top of one another gives us the foundation for making images and more data, such simply by associating groups of 8 bits called a byte with certain things such as data. Now, with all of the information I have given you, we can finally make a computer. So, to start, these are the parts and how they function in your computer. First of all, we need something to run, some sort of shell that can hold instructions for base functionality. This is where the operating system, or OS, comes in. The operating system is a primitive set of instructions that is the base set of instructions that the computer follows, allowing it to write other instructions. Just like the human body, which holds all of our parts, a computer has a motherboard, a large circuit board with places for all of its parts, as well as some of its own, such as an I/O board, which has all the USB and Ethernet ports you could need. A motherboard also connects all the pieces so they can communicate with one another. RAM is short for random access memory. This is where all the temporary information that the computer doesn't need to keep long-term goes. So where does the information that you want to keep long-term go? That's the storage drive, which can be in one of two forms. An HDD, which is a hard disk drive. It's a mechanical disk where your information is stored on said disk. And an SSD, a solid state drive with no mechanical parts, making it less prone to wear over time. On a solid state, your information is stored all electronically. Now, for the captain of the ship, the CPU, or Central Processing Unit. This transistor-filled masterpiece is what does all the calculations and instructing of the PC. The CPU follows three simple instructions that allow it to perform almost any task: fetch, decode, and execute. When a CPU fetches, it grabs info from other parts of the computer and then will decode it into binary, so it can read the instructions. Finally, it will execute, which is the stage where it performs what it is instructed to do. This could be anything from running a different process to performing as normal. Now, as an example, the process your computer goes through to get to Google may look something like this. You click on the Google executable file, exe for short. It'll send a signal from your solid state to your CPU, telling it that it's running Google. Then the CPU will respond by running any processes within that Google exe file. Normally, just a bunch of commands for the CPU to follow, which is more files for Google to need. That way it can run. Once Google is finally open, we are using RAM to view any image you might see on the front page, which includes the Google logo. So, to recap, I hope you all have learned from this that a computer is more than just one machine, with simple instructions such as do this or that, but instead, a bunch of smaller machines working together in their electronic cyber system with their own form of communication to perform tasks humans would have a much harder time doing on our own. Every day, we as humans are growing closer to technology, and perhaps someday we'll be digital ourselves. However, this is a very far future. And for now, the best we can do is remember with our fleshy, mechanical parts. I hope you all will intake what you learned today, store it, and possibly recall it for later. Thank you. Goodbye.